Alright, so the next concept is circles. So some basic information about circles. A circle is defined as a set of points that is equidistant from a given point. That given point is called the center, and I'll draw one right here. The radius is the distance from the center to each of the points on the circle, and the whole thing is called the circle. A chord just connects two points on the circle, so I'll draw a few chords right now, and the diameter is the longest chord. It goes right through the center, and the diameter is equal to 2 times the length of the radius. A circumscribed circle means that it circumscribes a polygon, and by circumscribing a polygon, that means that it contains all of the vertices of the polygon. An inscribed polygon means that a polygon circumscribes the circle, or the circle is inscribed. That means that each side of the polygon touches the circle at exactly one point. You could also say that the circle is tangent to each side, which is a concept that we'll talk about later. Finally, the circumference of a circle is 2 pi r. Next, we learned about arcs. So before we talk about arcs, let's talk about a central angle. A central angle is an angle formed with two radii as the sides of the angle and the center as the vertex. You can see that the central angle separates the circle into these two arcs. This one is called the minor arc. We'll call it arc AB. The measure of arc AB is between 0 and 180. That's why it's called minor. And it's also equal to the measure of the central angle. The major arc is the longer arc that goes all the way around. You have to identify it with the third point, which is what I did with point C, and its measure is between 180 and 360. So you can find it by subtracting the minor arc or the central angle from 360 degrees. Finally, a semicircle is an arc that has a measure of 180 degrees, and its central angle is just basically the diameter. You also have to identify it with 3 letters. To find arc length, you just take x, which is equal to the measure of the arc, or the central angle if it's a minor arc, x over 360 times 2 pi r. So you're basically just finding the fraction of the circle that the arc takes up and then multiplying that by the circumference. So congruent arcs have congruent measures and lengths, and they should be on the same circle or congruent circles. If two arcs are on the same circle or congruent circles and they have congruent central angles, then they're congruent. And if two arcs are in the same circle or congruent circles and they have congruent chords, then they're also congruent. If a diameter or radius is perpendicular to a chord, then it also bisects the chord and the arc. So for example, this diameter is perpendicular to the chord, so therefore it bisects the chord and arc. And if chords are equidistant from a center of a circle, then they're congruent. Remember that distance is the perpendicular distance. Alright, then we get into the concept of inscribed angles. So an inscribed angle has a vertex on the circle itself, and its two sides are chords. The arc it forms is called the intercepted arc, so we'll call that arc AB. The measure of the inscribed angle is equal to 1/2 the measure of the arc. So the measure of arc is also equal to 2 times the measure of the inscribed angle. If a bunch of inscribed angles intercept the same arc, no matter where they are in the circle, then they're all congruent. They have the same measure. And if an inscribed angle is inside a semicircle, then it's a right angle. Furthermore, opposite angles of an inscribed quadrilateral are supplementary, because as you can see, the sum of their intercepted arcs would be 360. Together they intercept the whole circle, and therefore the sum of their measures is half of that, 180. Next is tangents. So a tangent is a line or a segment or something that intersects a circle at exactly one point. It's perpendicular to the radius at its endpoint, so it's perpendicular to the radius that intersects it at its point of tangency. If two coplanar circles share a tangent, then it's called a common tangent. Common external tangents are common tangents that don't intersect the segment that connects the center of the two circles. So as you can see, these tangents don't pass through that segment. Common internal tangents do pass through that center segment, as you can see here. It goes right through that segment that connects the centers of the circles. So externally tangent circles are circles that are tangent to each other on the outside, while internally tangent circles are circles that are tangent to each other with one on the inside of the other. After that, we learned about secants. So secants intersect a circle at exactly 2 points, whereas a tangent only intersects at exactly 1. So the segment inside the circle would be the chord, but the secant would be an entire line. So secants and tangents have some special theorems regarding their use. So if two secants intersect inside of a circle, they form these angles. So this measure of an angle would be equal to 1/2 the sum of this measure of the arcs formed by that angle and its vertical angle. So if angle 1 formed arc AB and its vertical angle formed arc CD, then the measure of angle 1 is equal to 1/2 the sum of measures of arc AB and CD. If two secants intersect outside of a circle, then the measure of that angle formed is equal to 1/2 the difference of the larger arc minus the smaller arc. So you would take the measure of the larger arc, the one that's further away from the angle, minus the measure of the smaller arc. And this also works for secant and a tangent and tangent that intersect outside of a circle. If a secant and tangent intersect at the point of tangency, then the angle formed is equal to 1/2 the measure of the arc that's formed from the point of tangency to where the secant intersects the circle. Alright, so if two chords intersect inside a circle, they separate themselves into 4 different segments. If you multiply the segments of one chord by the segments of another chord, they're equal. If two secants intersect outside of a circle, then the product of the outside segments and the complete segments, the whole secant segment, is equal. So A times B would be equal to C times D. Outside times whole equals outside times whole. And if a secant and a tangent intersect outside of a circle, then the outer part of the secant multiplied by the whole secant is equal to the length of the tangent squared. If two tangent segments intersect outside of a circle, then the tangent segments are congruent. Finally, if you want to graph circles on a coordinate plane, the equation to do so is called center-radius form. X minus h squared plus y minus k squared equals r squared, where hk is the radius and r is the radius. As I mentioned, this is called center-radius form. General form is x squared plus y squared plus dx plus ey plus f equals 0, where d, e, and f are real numbers. If for whatever reason you're given general form and you need to convert to center radius, here's how you do it. First, you need to group together the x squared and the dx and the y squared and the ey while also taking the f to the other side of the equation. Then you need to complete the square, which you do by taking half of d and half of e and then squaring that and adding it to their respective trinomials. You also need to add 1/2 d squared and 1/2 e squared to the other side. Then you turn your perfect square trinomial into the square of a sum or the square of the difference, and there you go, you have your center radius form.